All right, so I found a better drawing tool to use. It's called auto draw, so it should be easier to draw with this time. I'm gonna answer two LeetCode easy questions, and I'm setting a new hard rule for myself. If I can't answer in 20 minutes, I'm honestly looking at the solution. I don't even give a fuck. Like, I'm looking at the solution. Like, I can't spend too long on easy questions. So we're gonna go through some of the other questions I've already solved again because I've forgotten a lot of the things because I kind of rushed it. Like, you already know from last thing. This is not even a video for people anyway. It's just for me, and just happened to come across this. Then let me just have another disclaimer. This video is not to teach anybody anything. It's literally just for me. I want you to know that this video is literally just for me. Arrays. So we're still doing array questions. Yeah, okay. So basically, let's just pick a random one. I won't even look. Blah, blah, blah. Click. Okay, whatever my mastodon's on. Boom. Remove duplicates from sorted array. All right, fuck. I hate these top questions. Those are some little tricky things to it. All right. This has a lot of dislikes, so I guess it was some bullshit question. All right, so given a sorted array nums, remove the duplicates in place such that each element appears only once and returns the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Clarification. Confused why the returned value is an integer, but your answer is an array. Note that input array is passed by reference, which means a modification to the input array will be known to the caller as well. Internally, you can think of this. Nums is passed by reference, without making a copy. Int length equals remove duplicates, nums. Any modification to nums in your function would be known to the caller using the length returned by your function. It prints the first length elements. So basically, okay, hang on. An example 112. Actually, I should probably make this a bigger screen. All right. 112 and remove the duplicate. So it's 1, 2. Your function should return length equals 2. So I should return the length of the uniqueness, essentially, right? Remove duplicates from sorted array. Remove duplicates from sorted array. Now, the fact that it's sorted, I start thinking of things like binary search. But obviously, things with duplicates, I start thinking of sets. So, isn't it just remove, what is it? It's just remove duplicates, no? No, this is remove them in place. This says given a sorted array nums, remove the duplicates in place such that each element appears only once and returns the new length. And returns the new length. I won't lie, I'm not going to draw this on my computer. I just find it, unless I get an iPad, I just prefer using a pen to draw something. If I'm being honest with you. Note that the input array, okay, so nums is passed in by reference, i.e. without making a copy. Any modification to nums in your function would be known by the caller. Using the length returned by your function, it prints the first elements. Okay, so if you're given 1, 1, and 2, the output is 1 and 2. Well, the output is 2, but the array is 1 and 2, right? Okay. Your function should return length 2 with the first two elements being 1 and 1. Okay, all right. It doesn't matter what you leave beyond the returned length. Okay. All right. We have 0, 0, 1. I prefer these longer examples. 1, 1, 2, 2, 3, 3, 4. So, okay, so we know that the array is sorted. Actually, when did I start this? All right, 4 minutes. So when this hits 24 minutes in record, I'll know it'll be 20 minutes. All right, so we know that the array is sorted. So what do we know? We know that every element to the right is just bigger, right? So what do we know? We know that if we, I think this could be an array question, a pointer question, because essentially the idea would be to keep track of the unique elements against the non-unique elements. So if this was a two-pointer solution, let's say we had a pointer at 0 and a pointer at 0, right? I really should get an iPad for this. I'll draw it on the screen again. It's just, I want to draw on paper first. So we have 0 and 0. Let's say we had 0 and 0, right? And essentially, if this is the unique pointer, and if this is the dupe pointer, basically unique, well actually, yeah, so unique pointer should, alright, so if these two pointers equal each other, if the unique equals the dupe pointer, then the dupe pointer should move by 1 until it eventually equals something that's non-unique, right? It should then swap the position with the dupe, with the old dupe, with the original dupe position, right? So, for example, 0, 1, 2, 3 index, if 0 is the unique element, 0, but 0 is the same as 0 when it's duped, so the first index, then move the dupe index by 1. So then dupe index is pointing at the first index. Keep track of the previous dupe that was, well, but then what if a situation if you had 0, 0, 0, 0 would move X, would move I amount positions to the right. How would I keep track of the original dupe? I mean, I could have a counter, I guess. Yeah, I could have a counter, 2 pointers, and then move the pointer, and then and then increase the counter. Yeah, okay. I think I got some here. Well, I don't think I'll embarrass myself as I did with the last one as much. So, remove duplicates. So I guess we could do something like we have our unique. This is our unique pointer. This is a unique pointer. This is our dupe. Okay. Dupe pointer. So we can say something like, so let's say dupe. This is our dupe tracker. Dupe tracker, right? Dupe tracker. Yeah. Okay, so for I in range length of nums. Actually, dupe should probably start at, no, yeah, that makes sense. Because let's say it was only one element, you won't need to account for it. You can move. Yeah, okay, that makes sense, I guess. Yeah, okay. So we can say if nums unique, so if the unique position in the array equals the duped position, equals the duped position, then move the dupe by 1 and then keep track. No, so yeah, we move the dupe by 1, right? Until eventually we get to the point where dupe is unique. So we get to a point where, so essentially, here's our array 0, 0, 0, 1. So we start, well, actually, 1, 1. So we'll ignore the rest for now. We'll just say this is unique. This is dupe. So when these two are the same, this should move here. So dupe. So dupe should essentially move. You know, for fuck's sake. Oh, this is why I need an iPad. Okay, fucking, I'll just draw it again. Dupe should essentially move here. What the? How did I move this shit? Oh, okay. So if dupe is here now, and if this is unique, dupe is here, unique is here, and if we have our dupe tracker, this is the dupe tracker. Well, actually, no. Don't need a dupe tracker because dupe tracker would always be the next thing after unique, right? So yeah, we don't need a dupe tracker. We can just say move that here, and then we just swap. Essentially, we say nums unique plus 1, nums unique plus 1. We swap it with the current dupe position. With the current dupe position. Yeah, so we swap this with essentially this. So then it becomes 0, 1. So we swap unique plus 1. Unique plus 1. Yeah, so we swap unique plus 1. Yeah, so unique plus 1 equals the position at dupe. Yeah, so we just do this. Yeah, and then we have 1 here. So then we can now move unique by 1. So then that way we have, how do I rub shit out? There's no eraser. Where's the eraser in this fucking bitch? Alright, oh my god, I'll just fucking delete it all then. Okay, so then now we have 0, 1, 1, 1. Unique is here. Dupe is here. Unique is here. This is 0, 1, this is 0, 2, 0, 1, 3, 4. So then dupe should move and move. Yeah, okay. Actually, that should be the whole algorithm, though. And then I just return. Well, I should probably keep track of the. Not just return unique, no? Yeah. Return unique. Because unique would be at the unique position. List end. Oh, yeah. Gotta, because when it gets to the end. I'm not paying for premium just to click a button faster. Output 1, 1. Outputs 1, 1. Alright. Let me just print out the array. See, well, actually, it would be a situation where we're saying if they're equal. However, put in the else statement. If they're not equal, then yeah, if they're not equal, yeah, okay. Empty. What? How the fuck is it empty? Well, technically it should be saying well, yeah, else, yeah, what the fuck, yeah, else nums unique, so else nums unique plus 1 equals nums dupe. Wait, hang on. If the two things are equal, then move dupe by 1. Move dupe by 1, right? Unique will always be at the position of the latest unique elements. Cool. So I'm just going to go ahead and print the array just so I can see what it's actually doing. We still got some time. Still got some time for this question. All right, so 1, 1, 2, but it's only printed 1, 1. So it's fucking doing nothing. What the fuck? Literally did nothing there. Absolutely did nothing there. Hang on. If unique starts at 0 and dupe starts at 0, we both start here and we're both saying if 1 and 1 is the same thing, move dupe to the right, right? So now we have dupe is 1 and thing is 1, right? If they are equal, move dupe. Oh, I see. This will swap it regardless. Okay, so this should be in an else statement if they're not equal. If they're not equal, then replace unique plus 1 because unique would be 1. Then replace the second index, the first index here, with dupe. Dupe should be 2, so it should be 1, 2. It should be 1, 2, 2. But it's going to give me an empty string. Why is that giving me an empty string? I don't get it. Nums unique equals nums dupe. And increasing dupe. And increasing unique. What's going on here? What's going on here? 112. Standard output. 112. 112. What the fuck? For I in range, yeah, I'm pretty sure, like, okay, hang on. For I in range, let nums. -1. Okay. Else. So, okay. We're going through the array, right? Character by character. I mean, element by element. And we're saying unique starts at the 0th index, right? So we're at, if I were to rub all of this out. So if we look at the array, 0, 0. Can I actually paste this here? Oh, yes, I can. Perfect. Yeah, so if we have our array here, 0, 0, 1, 1, 2, 2, 2, 2, we take a little draw-on tool. Unique is here. This is unique. And then duplicate is here. Well, originally duplicate is here, but it moves here after the first iteration. That's just to account for the fact if it's a one element array. So this is the second. So yeah, we move on. Dupe moves on because it said that 0 and 0 is not the same. Then now it's saying 0 and 0 is still not the same. So guess what? Oops, what the fuck? So guess what? We move this again, right? So now it's this and this. And now because they're not the same, right? Because they're not the same, what you want to do is essentially replace unique plus 1, right? Remember that this is unique plus 1. Let me draw that better. Oh man, this fucking pop filter is fucking dusty as shit. I fucking barely used it before today. Alright. Or yesterday. Alright, so this is unique. Oh, I need to get an iPad. Okay, unique plus 1. So the fact that these now we have unique and fucking dupe is not the same, right? What you need to do then is replace is swap them around. No, you don't swap them around. Nah. You don't swap them around. If you just make it equal thing. So this should then be 1. This should become 1. This should stay the way it is. Yeah, okay. So essentially, unique can now move here. Dupe can move here. It's still saying it's the same. It's the same. Boom. Now take the 2 and replace it with unique plus 1. Right? That's the worst arrow I've dreamed in my life. Now replace it with unique plus 1. So then take that and put it here. So it should be 2. And now, oops, oh my god. And now take unique and, oh man, my god. Take unique, oh my days, man. This is so fucking annoying. Take unique and now move it here. Right? What? This is not the same drawing. What are you doing? Okay, there we go. Yeah, and then now unique moves here. And you can see this is the same. This is the same. This is not the same. So then we then do the same shit. Literally the same shit, right? We then make unique plus 1 yet again. Make it 3. So now we have 3, right? 1, 0, 1, 2, 3. And we do the same thing again. We move unique over here. And now we see that duplicate and unique are the same, so we have to move duplicate again. Now we have to move duplicate again. Now we take the element of duplicate and move it here. Unique plus 1. So this should be 4. And then we return the length of unique plus 1, which is 1, 2, 3, 4, 5. So 5 should be returned here. Just as it said here. Yeah, 5 should be returned here. 5 should be returned here because this is unique plus 1. So then what am I doing wrong here? If I'm, here I am, if do plus 1, else, nums, unique plus 1, equals, nums, dupe. Yes. What's wrong? What's wrong with the array? Well, yeah, I mean, at the end, though, it should return this anyway, but I'm still kind of confused. Still kind of confused. What's going on here? Still slightly confused. That array should be, the array should be 1, 2, 2 at the end. It should be 1, 2, 2, and I should return 2, and then it should give me 1, 2. But it's not doing that. The logic, my intuition here is right. My intuition here is right. Which I don't have a problem with. But if nums unique equals nums dupe, if nums unique equals nums dupe, you know, I'll even explicitly say if nums unique does not equal nums dupe, right? Just explicitly saying it, just so I'm not just so there's no beef. Like, of course, I'm expecting it to change. Like, if they are equal, if they're different, right? Because it's saying if it's saying if the unique is the same as dupe, move dupe. That's all it's doing. That's all I need to do. Move dupe, right? Move dupe. Oh, wait a minute. I'm moving dupe, but I'm in a for loop. So I'm not ready. It should be a while loop, no? It should be while unique is less than the length of nums minus 1. Yeah, this should be this. This should work. Yeah, there we go, but it's out of index. Why is it out of index? Length of nums. Length of nums. If unique equals. If unique is less than the length of nums. While unique is less than or equal to the length of nums minus 1. Actually, no, because... Wait, what? Yeah. Or just the length? Because I'm accessing unique plus 1. This is going to be out of index. Well, you know, this is the array I'm trying to get. Like, this is what I was talking about. But why is this out of index? If nums unique equals nums dupe. What? If nums unique equals nums dupe. Dupe plus equals 1. If the fucking nums unique, this only goes up by 1 every time it's different. Unless, I don't want it to increment every single time. Or do I? No, I don't. No, I don't want to increment it every time because doing that results in, it should just be length of nums minus 1. What's the beef? What's the fucking beef? Why is this out of index? I don't understand. The dupe. Oh, yes, that's why. I should say, and dupe is less than the length of nums minus 1. Fuck. That's not right. That's not right at all. That's strange. That is very strange. That is strange. Man, I think the one thing with arrays is I understand more than all the other data structures, of course, who doesn't understand arrays the most. But my problem is always how to get these index out of error situation problems. Which, honestly, I should probably take that down. give a note to myself with that index out of error bullshit. I seem to always kind of fuck up on understanding why things are out of index, because I'm actually not seeing why this is out of index. I'm saying length of nums minus 1. How is it ever accessing beyond that? I mean, okay, so while the unique, god damn, bro. Okay, I will print. Okay, let me just print unique. Print unique. Print unique. All right, 0 0 1 1. 0 0 1 1. What is it? Is it a problem with the dupe? Well, that would be 2 over here. 0 1 2, because dupe is 2 over here. But it's saying the problem is this, so the problem must be dupe, right? Oh, the problem is dupe. Dupe goes to 3. Why does dupe go to 3? Dupe goes to 3. How does it fucking do that? How does it even go to 3? Because we start off... Huh? We start off at 0. We start off at 0. If we start off at... So you're saying that after it gets to the end of 1, 1, 2, you're telling me dupe becomes 3 at the end. If we start here and dupe is 0, if dupe is 0 at this point, dupe has to move... Dupe will move 1 here. Oh, I see. It's because we're comparing it on the same position, which counts as 1. So what needs to happen is dupe needs to be 2, and then we need to make a case for where, I guess, the length is 1, right? Yeah, it's still out of fucking range. Well, actually, no, yeah, should we put it to... Actually, no, that won't work. That won't work. Yeah, just like I thought. Wait, what? If dupe starts at 1, then... Oh, it goes 2, 2, 3, 3. Fuck. Why is this so out of index? I don't understand. If we start off... If dupe starts here... Dupe is literally starting at this position, 1, and then it goes 2. It goes... How does this become 3? I don't understand. How does that become 3? I just really don't understand. Uh, 2 more minutes. 2 more minutes, and I'll look at the solution. 2 more minutes. How the fuck is this? Wait, 0, 1, 2, 3, 4. Yeah, this is right as well. Like the array I'm making is correct. It's just dupe keeps going out of index for some reason. This is saying at the end dupe is 10. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in here. What? I don't understand. I genuinely do not understand why it's doing that. Okay, how about... Nah, I can't do that because unique plus 1. Huh? Dupe... If I compare dupe minus 1... What if I did this? Because if we start at 1, it's like doing the original check I was doing it anyway. Still out of range. 11. It even gets worse. Even gets worse. Why is this out of index? I don't understand. Why does dupe keep going out of index? How was it even making that many comparisons? We start off at... that doesn't make sense. Alright. Alright, so we literally start off at here. We literally start off here. Right? Dupe... In the scenario where dupe starts here and unique starts... Well, actually, let me draw it better so that way it can be drawn easier. I mean, moved easier. All right, so we have unique here, and we have dupe origin. Let's say dupe originally started here, where I was originally saying, because these are the same dupe moves, right? They're the same, so dupe increases by 1. It increases by 1, right? So actually, dupe is 1 here. Yeah, dupe is 1. Dupe is 1. Increment it. It's still the same. Dupe then becomes 2. Dupe becomes 2, right? Dupe becomes 2. 0, 1. Ah, I see the fucking problem. Because when we have... Yeah, I see the issue. When we move dupe over here, now dupe is 3. Dupe becomes 3, which clearly isn't an index. But then, if dupe started off as -1, it did not. It doesn't fucking work as well. Yeah, if dupe started off as 0, it would be out of index. All right. Yeah, I'm not sure why. I'm gonna quickly look at this solution. I think I've done this. Yeah, I've done this before. So let me see what I did. Let's see what I did. Oh, okay. It seems like there's some similar actually. Oh, I didn't have 2 pointers. I had 1 pointer. I started at 1 and said if they're not equal, then move. Oh, okay. This was edited in place. Dupe index +1. Dupe index +1. Is that because of the way? Oh no, that's the same shit. If nums I -1 does not equal, so oh no, I did. Oh wait, I did that. I used a for loop here. Same. Well, to be honest, it doesn't matter if I use a for loop or a while loop. It's the same thing should still work. It seemed 3 weeks ago. It seems I didn't forget everything. It is a very similar solution, but I'm trying to think. Yeah, I said if the previous element doesn't equal the current element, then I said that the dupe index +1. Yeah, and I increased. So I just. Oh wait a minute. I'm saying here if they're equal, increase the dupe. If they're equal. But this is, I said here if they're not equal, increase the dupe. Why did I say that? If they're not equal, increase the dupe. If D, okay, wait a minute. If I have D over here, UD, and if they're the same, right? If they're the same, then you should just move dupe. What the fuck? By 1, like, what do you mean? Like, but that puts it out of fucking, that puts the shit out of, no, wait, because it's indexed by, that is interesting. So then it would have to be every single time we go through it, dupe has to go down by 1, right? For it to index it. Nope, that doesn't work. That's problematic. That's problematic. Huh. If the current element equals the dupe element, what the fuck is going on here? The shit. Anyway, if the current element, yeah, what? I said if they're not equal, increase dupe index. Why would I say that? Why did I say 3 weeks and 3 days ago increase the dupe index if they're not equal? Why would I do that? Why would I do that? Why would I have done that? Because if they're not equal, increase the dupe index. Well, if they're equal. Oh, wait. If they're not equal, but if they're equal, nah, see, that works here because this is starting over here, right? And I said if the previous doesn't equal the current, if the previous doesn't equal the current. No, wait, hang on. I can do it in my while loop. The fuck? While unique is less than the length of nums. Okay. Well, actually, to be honest, all you have to do is say and dupe minus 1 is less than the length of nums minus 1. This should solve the problem. There we go. I knew I wasn't crazy. So I did this originally with a 2 point. Well, actually, let me submit it to see if I'm trying to share. No. Yeah, so I did this with a 2-pointer solution here. This, you can do it here with a 1-pointer solution. I just kind of like thought of a 2-pointer here. But yeah, that's pretty cool. Yeah, so what were the lessons learned in this question? This was a 2-pointer. So the lessons here, you can, so you know, be wary of 2-pointer array questions. Be wary of 2-pointer array questions. I think pretty good. And be wary of 1-pointer array questions. That's kind of like the lesson here. Just, you know, that's not really a lesson, but whatever. All right, let's move on to another problem that I've already solved, but I kind of want to recap the stuff. So difficulty, easy, status, attempted. Nope, not attempted. Solved. Still recording? You still recording? All right, just pick a random. Is this all of them? Yeah, it's all of them. Just max consecutive ones. Oh fuck, man, I hate these. I hate these type of questions. I'm gonna wait to. All right, thought the solution was there for a second. It seems not a lot of people have done this question. It only has some amount of votes. All right, what's this? Given a binary array, find the maximum number of consecutive ones in this array. The first 2 digits or the last 3 digits are consecutive ones. The maximum number is... All right, so what did we learn yesterday? We learned when you hear the word maximum or minimum, you think of dynamic programming or greedy algorithms. You think of one of them, right? Now, this to me... All right, first let me get the physical notepad out. You have to get the physical notepad out. So our only example is 1, 1, 0, 1, 1, and 1. And basically collect the maximum ones. So in fact, I can imagine this as a greedy mixed with a 1-pointer solution. I can imagine just for looping through it, looking at, hey, this is a 1, this is a 1. Count it. If it's not a 1, it breaks it, then you're done, right? And keep track of the max, essentially. So yeah, it definitely seems like a greedy fucking thing. So I don't even remember. To be honest, I don't remember even doing this question at all. Don't remember doing this question. I didn't even thumbs it up or thumbs it down. All right, so we start off at index 0 and we see it's a 1. Well, we have our max variable. Set it at float minus infinity. Why am I doing that? I am doing that because because if everything's bigger than minus infinity, other than minus infinity. So the idea is that you want to get the initial maximum set right, because there could be in a situation where you have an array where zeros are part of it, and zeros could be valid maximums in some situations, right? So let me just get out my emails coming up. Okay, yep. So we start off at index 0. We have a max thing. And we essentially we should have a current, like within the current for loop, like kind of a temporary array that keeps track of the current max, right? So we have like a current max that keeps track. So whenever we see a 1, we add 1 to this value, right? And then each time we make a comparison against max, right? Until every time it's broken, every time a 0 breaks this trend of 1s, then we keep track of that max before we reset current max again. All right, so this doesn't seem too hard. This does not seem too difficult. But, we'll see. All right, so we have our max 1s equals float. And this is kind of why I like, even though I love complaining about LeetCode, I like making fucking all kind of jokes about it. It's, I think LeetCoding kind of really makes you understand the language you're working in way more than kind of the really, really small properties of the language, more than, like, let's say a project would, in my opinion. Because with a project, you might have more freedom to do certain things, but this is kind of like bare bones, just fucking, here's the language. Can't really use any libraries. Well, you can in LeetCode, but no one really does that unless you're answering like heap questions or something like that. But I kind of like this. Kind of like, like that float infinity trick, wouldn't have thought of that if it wasn't for LeetCode. Anyway, max 1s is float minus infinity for... So as we're saying, we could say for I in range, length of nums. We have our current ones, right? Our current ones, which is our, oh my days. Current ones is 0. If nums I equals 1, these are integers, yeah, if equals 1, then current ones plus 1, right? Plus 1, else, well, yeah. Yeah, so if the current thing is 1, and it said, in our notes, it says the input array will only contain 1 and 0, so we don't have to say, like, if it equals 0, we just say else. So else, if it's 0, then we get the max 1s equals the max between the current max 1s, which is flow infinity at the start, and the current ones. Right? So... Actually, I think below here, this should be reset to 0, right? Current 1s equals 0. Something like that. And then we can return max 1s. 20 minutes on the clock, 20 minutes on the clock. Output 0. Great. That's just great. That's just splendid. Hang on a minute. Current 1s. Wait, for I in range, current 1s equals. If it equals 1, update current 1s. Should I compare max each time? Compare max each time. And then otherwise reset it back to 0, right? And then run. 1. Okay, why is that 1? nums I equals 1, current ones plus equals 1. If it's a 0, reset current 1 to 0. I want to do this with all one space. Obviously, I could just add all these to an array, or an array within arrays if I wanted to. Or I could add it to a dictionary, but I won't do that because it makes extra space. So it's not the best way to do it. So let me think for a second. If current one is 0 at the start, right? Then we see a 1, we make current ones 1. We see another 1, we make it 2. Even if there was some bullshit happening with this else, like this should still be 2. Why is it not 2? Current 1 is 0. If nums I, well, actually I think it's because this keeps resetting it. It is not the case. So this should be actually outside, and it should be like this. There we go. So let's see. Please be right. Please just be right. Don't make me have to do some stupid edge cases. Come on. Oh, fuck's sake. Oh, yeah. In this case, it's got to be 0 because. Yeah, okay. That makes sense. That makes sense. Ah, yay. There we go. There we go. Not bad at all. 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 I think you can see I solved this on the 28th of October, but I swear to God, I don't remember looking at this at all. Like, I literally do not remember looking at this at all. But I think this is a pretty optimal solution. It's definitely a greedy solution, but I think it's optimal because we're not returning any extra data structures, so the memory is 01. It's constant. We are checking it in ON time. I don't know why this is so slow. But the memory is just, I actually don't know why this is so slow, but I don't really care about leetcode fucking whatever. But it's pretty good, yeah. I mean, max, and here's the thing. Max is ON if you're comparing, of course, looking at a whole array or something like that. We're not doing that in this case. We're just comparing two different constant variables. Max ones, current ones, two integers. So that's an O1 operation. Yeah, looks good to me. I think today was a successful leak coding day. We did 2 easy problems. I don't even remember what was this considered one. This is 485, and I don't even remember what was the last one we just did. We did what the fuck did we do? We did remove duplicates from sorted array, which is 226. That's one of the early questions. Yeah, so I think today was a pretty good lead coding session. I think tomorrow I'll probably do one medium question. So here's my strategy. In case somebody for some reason is watching this video, here's my strategy. Don't kill yourself, right? Do not kill yourself because you will forget things the same way I did. Like, you just can't cram this shit. This is not an exam, right? There's too many questions to memorize. You're not trying to memorize them in the first place. You're trying to get some real benefit. Yes, you are trying to get the job, but at the same time, you're trying to get some real benefit out of it, right? You're trying to be able to think algorithmically, right? You want to be able to answer a question you've never seen before. Yeah, so you can be a prideful, pretentious piece of shit. Yeah, that's why you want to do it. But all right. So, yeah, good day. We did this in under an hour. Yesterday literally took us an hour to answer one question, and I still had to look at the solutions. I think today was a good, successful day. Move on to the next one, and I will talk to myself later. I mean, tomorrow. Nee, ushi tora ni tatsu. Oops. Talk to you. We're saying on Chidori, all that good shit.